Hi everyone. This lecture is going to have two learning goals. The first is to understand the key features of experiments, and the second is to understand different types of experimental designs. Up until this point in the semester, we've been really focused on survey methods, so looking at people cross-sectionally or longitudinally, and trying to observe and measure relationships between variables, so observe and measure independent variables, dependent variables, and then potentially statistically analyzing, looking for associations between those variables. And today we're going to pivot to thinking about experimentation, which is a slightly different approach to doing research, where we're not just looking and measuring our variables and looking for relationships between those variables. We're actually going to act and manipulate a cause to try and observe an effect. We're going to actually intervene in the world and try to change and mess around with our independent variable and see if that leads to a change in our dependent variable. The important and really useful thing about this approach of experimentation is that it's not just going to allow us to look for associations between variables, it's actually going to help us establish these two other elements of causality, both time order and then ruling out plausible possible confounder variables. We'll look at how this works as we go through the lecture today. And what you'll often hear researchers talking about is that experiments and what are sometimes called randomized controlled trials, or randomized controlled trials, are the gold standard for assessing causality. So out of all the methods we could be using as researchers, a nice high quality experiment is going to be the best tool that we have to establish causality, with some drawbacks and limitations, which we'll talk about later. But key here being is that because we're actually intervening in the world and going out there and trying to manipulate a cause and seeing what the effect is, we're going to be able to establish the time order of these changes, and we're going to be able to rule out, based on some features of our design, many other possible confounder variables. So this is going to be the gold standard because it's going to be putting a lot of these pieces into place to support the causal claims that we might be laying out in our hypothesis. So what do we mean when we say manipulate the IV? Well, what we mean is that we're actually going to be doing something to participants in our study. We're not just going to be asking them questions. We're not just going to see, hey, how much did you use social media use yesterday? I'm actually going to make you use social media, and then I'm going to see what happens to you down the line. And what this looks like in practice for an experimental design is that I'm going to have what we call treatment groups, and I'm going to have control groups. To have a fully formed experiment, I need at least one treatment group and at least one control group. But I could have more complicated studies where I have multiple treatments, multiple versions of a treatment, and maybe multiple versions of a control group. When I say treatment, it's the group that receives some kind of experimental treatment. And when I say control, it's a group that does not receive that experimental treatment. We looked at an example way back on the first day of class, this kind of very basic experimental design where I might have people come into the lab and I might have some of them play on TikTok for a bit, I might have some play on Instagram for a bit, and then some, just sit quietly for a bit. And this would be a version of experimental design. I'm actually having people coming into the lab, I'm having them do different kinds of activities, and then I'm going to see what the effect of those activities are down the line. Continuing with this example of social media use and attention problems, I might invite 90 college students into the lab, and I might assign 30 of them to scroll TikTok for 10 minutes. I might assign 30 of them to scroll Instagram for 10 minutes, and I might assign 30 of them to sit quietly for 10 minutes. If my interest is social media use and attention problems, I might say that I have, in this case, two treatment groups. I have two different types of social media that participants are playing around with in this study. I have my TikTok group and my Instagram group. And in this case, I might have one control group, those who are sitting quietly, those who are not engaging with social media for 10 minutes. You can imagine different versions of a control group. Maybe I want these people to actually do something for that 10 minutes. Maybe I have them watch TV for 10 minutes. Maybe I have them read a book for 10 minutes. Whatever you think might serve as an appropriate control for scrolling on social media for 10 minutes. And this is where a lot of arguments come into play about experimental design. When you critique an experiment, looking at that control group to see what they did is really important to determine if you're really buying the kind of story they're selling about the study that they did. But for now, let's just take this example. 2 treatment groups, TikTok, Instagram, 1 control group sitting quietly. After that 10 minutes, I might then see how long you're willing to spend doing some kind of difficult task. Maybe I give you a difficult puzzle or a difficult set of math problems or a difficult passage to read, whatever it might be. And I say, okay, now you're going to spend 10 minutes doing this activity, and I see how long you're willing to spend doing it. Maybe it's a really frustrating, maybe really difficult activity. And I would have predictions then to say those who, were scrolling social media, maybe are going to be less attentive, less focused on this activity that I give them afterward. So I'm actually kind of creating these situations in this experimental context to see when you do this thing for 10 minutes, how do you then behave and perform on this thing for the next 10 minutes? So I'm creating situations to actually say, when I mess around with this independent variable, what is the effect? What does it look like on my dependent variable? And so in this case, you might get a score out of 10 minutes. How long did you spend doing that difficult task? Again, just thinking for a moment about what this would look like in my actual data file. In this case, again, I'm going to have, and maybe I have 10 participants or at least 10 examples here. Their ID numbers rather than their names, again, kind of protecting privacy, anonymity, all that stuff. It's going to look very similar to kind of the survey example we had a few weeks ago. But in this case, you're going to be assigned to a particular experimental condition. So in this case, I might have those who were on TikTok or those who were on Instagram. And the important thing here is that the numbers that I'm assigning to the experimental group, or the different groups that I have, the treatment groups and control groups that I have, these are completely arbitrary numbers. Again, these are categorical variables that we're working with here. By nature of doing an experiment, I am creating these groups, and I am then comparing these groups on some outcome. These are categorical. So it doesn't matter, is TikTok group 1, is Instagram group 1, is control group 1. I just need to assign numbers to these groups in order for this statistical program to kind of recognize how many groups do you have here. So each participant is going to have their kind of group assignment. I'm going to turn that group assignment into a set of numbers. The important thing being that the numbers that I'm assigning are consistent across the sample. I don't want to make one person TikTok number 1 and one person TikTok 2. No, anyone in the TikTok group is number 1. Anyone in the Instagram group is number 2. And then each of them are going to get this score, time on task, for how long they spent out of 10 minutes doing this difficult task afterward. And so if we map this out, we'll have each participant, this could go up to my 90 participants, for example, gets a score of 0, 1, or 2 for their condition number. Are they the control group 0? Are they the TikTok group 1? Are they the Instagram group 2? And then how long did they spend on this difficult task? And then I'm going to have this big data file with all these numbers, and I'll be able to statistically analyze them, which again, we will look at later in the semester, but I just want you to, for now, be visualizing, once I've collected this data, what is this data going to look like? What am I going to be working with? Beyond manipulation, the second really key and important feature of an experimental design is this thing that we call random assignment. And what we mean by random assignment is that all study participants have an equal chance of receiving the treatment or the control, or treatments or controls if we have more than one of those groups. Why this is important is that this is avoiding issues around self-selection that kind of plague survey research, that plague these relationships that we might look at in a survey context. And this is going to rule out, by nature of kind of removing issues around self-selection, it's going to rule out most confounder variables. You might say, this is making no sense, but let me give you a practical example so you can kind of see how this looks. So taking our example of social media and attention problems, a few weeks ago when we were thinking about alternative explanations, we said, well, hey, if you do a survey and you see this relationship between social media use and attention problems, there might be a confounder variable. It might be that really stressed out people use social media more, and really stressed out people have worse attention. And that it's really stress that is kind of leading to changes in both of these variables. And that makes a lot of sense. So in my experimental setting, I don't want to let people come into the lab and decide, are they going to scroll TikTok? Are they going to scroll Instagram? Are they going to sit quietly? Because we might find that really stressed out people prefer to scroll Instagram, maybe to forget about their problems. And less stressed out people are willing to sit quietly because they don't mind, being alone with their thoughts for a few minutes. So rather than letting them pick the condition that they're in, I'm going to randomly assign them to condition. I'm going to choose which condition they're in with random assignment kind of supporting me in doing so. And by doing that, I'm going to control for the potential influence of this confounder. So we're going to look at this visually in just a moment, and we'll be using these little faces as an example. Each of these little faces I want you to imagine is a participant in my study, and that participant in that moment as they come into my study is experiencing a different level of stress. Maybe some of them came from taking an exam, some of them came from sleeping, some of them came from lunch. They're all in a different kind of state of stress as they come into my experiment. I have some really angry, stressed people represented by this angry face, some really, really happy, less stressed, unstressed people that are yellow thumbs up face, and then some who are just feeling all right, this kind of neutral, kind of gray face. So as people come into my study, rather than letting them choose which condition they're going to be in, I'm going to let random assignment do it for me. And so what is that going to do? It's going to ensure that individuals, both stressed and non-stressed individuals, are evenly distributed across my treatment and control conditions. So in practice, what this would mean is that my first participant comes in, maybe they're a very unstressed individual. They just woke up and they're feeling great. And I flip a coin, heads or tails. Heads, they're going to the experimental group. Tails, they're going to the control group. And so they get heads, they're going to my experimental group. Second person comes in, maybe this is a very stressed individual. I'm going to do the same thing. I'm going to flip a coin, heads or tails, heads going to the experimental group, tails going to the control group. And in this case, they get tails, and so they're going into my control group. I'm going to keep doing this for each individual that comes into the lab. No matter how stressed they are, it's going to be a flip of the coin. Is it heads or tails? Do you go to the experiment or do you go to the control? Where are you going to land? And I kind of show this up to 10 people as we've been doing in all these examples. Each person, it's a random choice of the coin, heads or tails. You can imagine if I had more treatment groups and more control groups, I might need to use just a random number generator for it to say, 0 to 4, which condition are you going to be in? But in this case, just 2 conditions. I can flip a coin. It's up to chance. It's not up to me. It's randomly just up to the fate of the coin to decide which group are you going to be in. And you might say, okay, well, what does that do? And I'll show you. And so here's what it does, is that if random assignment works as it should, and most of the time it will, with a caveat, which I'll mention in a second, we should find that the number of stressed people in our treatment group and in our control group are relatively equal. Our number of unstressed people in our treatment group and our control group, relatively equal, and our number of neutral people in our treatment group and our control group, relatively equal. So although each individual is kind of varying in their level of stress, overall, my groups as a whole are relatively equivalent on this variable. They're equivalent on their level of stress. And that's the important thing about experiments, is that I'm no longer looking at just kind of each individual in my study. What I'm interested in are these group differences. Amongst the 30, 40, 50 people that I had scroll Instagram, what do they look like now on my outcome variable compared to those in my control group who maybe did this other activity? And this is theoretically going to work for any possible confounder I can think of. So age is going to be evenly distributed across conditions. Gender identification is going to be evenly distributed across conditions. All of these possible third variable confounder variables going to be evenly distributed across conditions. Now, because it's working with random chance, it's not always going to work. Sometimes these are going to be unbalanced conditions, which is why if you have very important or very concerning possible confounders that you'd really like to confirm that they're evenly distributed across conditions, you can also include measures of those variables. So I could ask each person coming in to rate on a scale of 1 to 5, how stressed are you? And I could double check to see, once I've done my study, the number of stressed people were kind of evenly dispersed across conditions. The number of men versus women versus non-binary were evenly distributed across conditions, and so forth. So you can double check this to be sure that it works, but by and large, most of the time when you're leaving it up to random chance, it's going to work out. And again, the key point being that I'm no longer comparing individuals to individuals in this study. I'm now comparing my treatment groups with my control groups on whatever outcome variable that I've then gone on to measure, in this case being attention. How long do you spend on this difficult task after you've scrolled social media? So those are the basics of experimental design. I'm going to manipulate my variable, my independent variable, by assigning you to treatment and control groups. And I'm going to remove the effect of self-selection by having random assignment choose which group you're going to be in. Now, within the confines of that kind of design, there are different structures of experimental designs that I can imagine. One key point of differentiation is that for experiments, I can have what's called a between subjects comparison. These are going to be comparisons that are made between different groups under different conditions. So I'm comparing groups between each other. So for example, those who scroll TikTok, or those who scroll Instagram, or those who scroll quietly, or those who sit quietly. I'm going to compare these groups. Each person in my study has only done one of these things and not the other two things. And this is good because it's going to avoid issues with like fatigue, with sensitization. I'm not observing you in each of these different situations. I'm just looking at you in one of these situations. So rather than have you do 3 things each for 10 minutes, I'm only having you do 1 thing for 10 minutes. So it's a shorter study. I'm not expecting you to do all 3 of these things. And it's not making it obvious, what are these comparisons that I'm making? If I have you scroll TikTok, then scroll Instagram, then sit quietly, you might start kind of getting an assumption or a guess about what I might be looking for in that study. And so I'm not sensitizing you to the underlying purpose of the study if I assign you to only one of these things. I might not tell you what the other groups are. I'm just going to have you do this thing and see what happens. This is opposed to what we call a within subjects design, which in this case, participants are going to be compared to themselves under different conditions over time. So I might have you sit quietly and then scroll TikTok and then see, amongst all of you when you were sitting quietly, how long did you spend on this difficult task compared to all of you when you were scrolling on TikTok, how long did you spend on this difficult task? The benefit here is that it's going to require fewer participants overall because I can make kind of these comparisons with a smaller number of people. If I have 40 people that each do each of these activities, I probably only need 40 people for that study. Whereas with a between subjects design, I might want 40 in each of these conditions so that I'm still kind of comparing 40 across these 3 different activities. But again, there's maybe some issues with fatigue, maybe issues with sensitization. If I have you do 2 things for 10 minutes each, a 20-minute study is longer than a 10-minute study. So you might be getting tired, you might be behaving differently because of that. And you might be a little more aware of what I am looking at in this study if you're sitting quietly for 10 minutes and then scrolling TikTok for 10 minutes. So just things to keep in mind, but understand that when I design these experimental contexts, I can compare groups to other groups, or I can put a single group through multiple different kinds of experiences and look at how that group differs across these experiences. When we are actually describing and identifying the nature of an experiment, we are going to identify our experiments by what we call factors and levels. And so these are just terms for things we're already looking at here that we want to be aware of when we're reading about and talking about experiments. A factor is going to be each independent variable that I've manipulated in an experiment. So far, we're really just talking about manipulating one independent variable at a time, but it is possible to manipulate multiple independent variables at a time. And the levels are the specific groups or specific conditions within each of those factors. So the example we've been working with so far is that I might have a group that scrolls TikTok, compare them to a group that scrolls Instagram, compare them to a group that sits quietly. In this case, I have just one factor, the activity that they engaged in. This is between subjects because they've each only done one of these activities. And it has 3 levels because there's 3 different activities that they could have participated in. So 1 factor between subjects with 3 levels. This is opposed to the other example I proposed, which is that I could have one group of people sit quietly and then that same group of people scroll TikTok. In this case, it would be 1 factor, still activity type, within subjects, because this one group is engaging in all of my different experiences. And it has 2 levels. There's sitting quietly and there's TikTok. If I wanted the same group to then scroll Instagram, it would then be 3 levels because I still have just 1 factor activity type, but 3 different activities that they're engaged in over the course of the study. So importantly, each experiment identified by its factor and levels. Levels are the groups within each factor. The factor is each independent variable that is manipulated. These are 2 very simple designs: 1 factor between subjects experiment, 1 factor within subjects experiment, 1 with 3 levels, 1 with 2 levels. Number of groups that I'm comparing. This gets a little trickier. We'll keep it pretty simple for the purpose of this class, but I just want you to be aware that experiments can actually combine multiple factors at a time. So let's take this example of sitting quietly and then scrolling TikTok, this within subjects design where I'm going to have you do this thing and then do that thing. You might say, okay, well, that's great. I can see how attentive you are after sitting quietly and see how attentive you are after scrolling TikTok. But I'm sort of concerned that you're doing the sitting quietly first and the TikTok second. People just might be annoyed by the end of the study because you've had them do all these activities and now they're getting tired and they want to leave. And that might be why you're seeing TikTok be less attentive than sitting quietly. And I could say, okay, well, I'm going to have some people sit quietly and then scroll TikTok. And then I'm going to have some people scroll TikTok and then sit quietly. So I'm going to what we call counterbalance these 2 different orders. And so in this case, I would have 2 factors, each with 2 levels, and we would call this a 2-by-2 design. So factor 1, factor 2, factor 1 has 2 levels, factor 2 has 2 levels. And here's what it would look like. First factor is the activity type. It's within subjects. I have 1 group. They're going to sit quietly, and then they're going to scroll TikTok. So I have my activity with 2 levels, 1 group doing this and then doing that. And now I'm introducing my second factor, which is the order in which they've done this activity. Now I'm going to have some participants do sitting quietly and then scrolling TikTok, and then a separate group of participants who are going to scroll TikTok and then sit quietly. So here I have a between subjects factor here with 2 levels, which is that some are scrolling first and some are scrolling second. So I've added a layer of complication to my study, but this is going to let me look to see, did order of activities actually matter, or is it that regardless of what order you did them, attention was worse after you scrolled TikTok than when you sat quietly? So the benefit of this is that we can start to try and rule out some of these explanations that people might generate based on, the unique artificial circumstance you created for the experiment. So, maybe by randomization, psychological stress is no longer a concern as an alternative explanation, but the nature of my design might lead to other kinds of concerns. And so I can design more complicated experiments to try and methodologically account for those potential issues people might raise. So don't worry too much about this more complex design so far. Right now, just kind of understand experiments. We have factors, which are the independent variables we're manipulating, and then the number of groups within each of those factors are going to be the levels. All right, and just to revisit our key learning goals here is that we want to understand the key features of experiments, specifically that we're manipulating independent variables and we're randomly assigning participants to condition. And we want to understand different types of experimental designs. We can have between subjects experiments or within subjects experiments. With between, we're having participants engage in only one of the different activities I have in the study. And within subjects, I'm having each participant engage in all of those activities in the study. And we identify our experiments by factors and levels, and we can kind of combine various dimensions of factors and levels for kind of more complicated experiments. The benefit there being that I can try and rule out methodologically some alternative explanations that critics might pose for the studies that I'm doing.